Hello and welcome back to the live stream. So last week we passed a whole bunch of declaration specifiers like static and extern, which allowed us to write programs like so we can now create function local statics, and even though they have the same name, they're mapped to different global variables. The name here in the print isn't important, so that's not a collision. They're different variables because we print different values, right? We first print this 11 and then the 42 from the function because we've got two different variables here. What we didn't implement, so what we're also parsing is external declarations. So for example, we can do something like this and then print. Now, because of the extern keyword, this is not a variable definition, this is a variable declaration. Yet, first of all, this is wrong because we're creating a local variable, which is like this is a global. And even if we add it at global scope, we are creating a definition for the global variable, even though there isn't one. Here's actually what happens if we then add a later definition. Right, we're getting a duplicate declaration error. So we need to tackle that somehow. So what's the best way to accomplish that? I believe let's start by what causes that error. So duplicate declaration, right? When we insert it, so when we insert it, we need to check whether this might be this might be a declaration, and then we are allowed to like sort of replace the declaration instead or something. I believe that's the best way of tackling it. So let's tackle declaration. So there can be in two states a declaration. We can have forward declaration, or we can have a definition. So let's add a query bool has definition. Bool def, and let's say initially this is false. So in the AST we don't need to keep declarations. So what I mean by that is this creates a declaration for a global variable, and then this creates a definition. But we don't need to create a separate node in the tree for that. We can simply modify the existing one. Because if we reach this point, because C is passed from top to bottom, if we reach this point, everything that only relied on the declaration is already been processed. So we can just modify it. So we don't need to like has definition and don't need to like modify it by don't need to modify it. What I want to say, don't need to modify it to add like the actual definition. We can just modify it in place. So let's say a declaration, it can have a definition, and that starts out as false. And then let's add a modifier, make definition, that simply sets this to true. Okay. And then let's first of all print that. When we print a declaration, at the very end, we can say if let's say if it doesn't have a definition, then we want to print declaration only. Oh, let's say no definition. So we can see what's going on. Okay. And then in the compiler, for example, let's not tackle this one first, but when we, for example, pass declaration, we need to check whether this is. So we're getting invoked to create like a list of declarators for that declaration, and then we need to mark them as definition if they are in fact definitions. So syntactic wise, this grammar production cannot be used to pass function definitions. So what the rule here is something in here. So is it a definition? If this is a function declarator. I think let's not do it here. Let's do it when we actually handle the declarators. So when we are parsing a function declarator, this is never a definition. This is never a definition since we don't have a function body. So we don't need to worry. But when we create a variable, this is a definition unless we have the extern keyword. So we create the variable. If we don't have the extern keyword, we don't have extern, then this is a definition. Okay. So if we have the extern keyword, how do we detect that? So we don't get the keywords, we get like this type with specs, and this creates like the linkage. So I'm guessing like if the linked has been explicitly set. So when do we set the linkage to extern? When we have the extern keyword. Let me get the digits. So we set it to extern only if we have the extern keyword. Okay, so we can say that if we don't have extern, which means if the linkage is not linkage external. Okay. If the linkage is external, we have used the extern keyword at the declaration. This makes it a forward declaration of the variable. Okay, let's see what happens when we do that. Oh, why am I in release mode? That's why it took so long to compile. Default. Okay, I was wondering what was going on there. So we still get those errors. So let's see, we just have a declaration. So this creates an external global without a definition. So that's good. Because this has external. Then the next thing is to adjust the code for insert new decal. So so this takes a declaration and inserts it into the symbol table. Replaces it, right. So it replaces if we already have this one. So in this case, we only want to create an error if we have a duplicate definition, which is the case if shadowed has definition and decal has definition. Then we have a duplicate definition and we want to issue an error. Otherwise, we allow otherwise we can. So there are two cases now. If shadowed has a definition and decal doesn't have a definition, then so this would correspond to something like we already have one and then we do that. That's perfectly fine. We just need to verify, check that we have the same declaration, right? Because we can't do something like unsigned int now, because this would be a type mismatch, so we need to check that. And then the other case is, so we need to do that in either case. And then if we have, like so, if we have a declaration and then a definition, we want to replace the existing one, which I'm guessing we already did. So back in that case, we added a definition, then we add a declaration for it, and this replaces the definition in the symbol table because we are calling insert or shadow. So then we need to undo that. So if shadowed has a definition and our decl doesn't have a definition, we replaced the actual definition of the thing. Undo that. Yes. So we replace the actual definition of that thing. We need to undo that. So we essentially do another insert. Insert or shadow of the name shadowed. We replace the actual definition of the entity, because we want to keep the definition and don't want to have it replaced by a later declaration. Okay, let's add an assert here that the name is the same. It should be, because, right, it's shadowed should have the same name. Okay, now we need to check that we have the same declaration. So the type needs to match, not what's the other function now of equal types is same. It's same. So we need to have the same type. Type and decl type as log. Essentially, we can copy this code. Redeclaration of with a different type. I don't think we. Okay, and then we've got shadowed and decl. So let's see what that's doing. It didn't work the way I wanted it to. So we didn't get an error. That's good. And we've got one definition and one declaration. That's also fine. That's not fine. This node shouldn't exist. This should have been inserted. Let's see what happens if I do that. Right, the redeclaration has a different type as expected. And if I do that, right, so we apparently this doesn't work. This logic. Why doesn't it work? So here we create a declaration without a definition, and then oh right, just because we modified the symbol table, what we're doing there is completely irrelevant. We also need to so we need to return something. Also need to modify that into the tree. Let's return bool. So and we want if shadowed is not null. So let's flip the log. If shadowed is null pointer, we are fine, and we want to return that declaration. Otherwise, we need to do a bunch of checks. And in this particular case, let's also use early returns here. So let's just keep it. And here we don't actually want to keep the declaration. So we don't want to keep the declaration without a definition. right? Because we have a definition, so why keep the declaration out? Returns true if the declaration should be added to the tree, false otherwise. Tree, not tree. So on a decl statement, what are you? I believe. Wait, what? Insert new decl. But this only adds to the symbols. Why are we only inserting it to the symbols? I'm guessing that has already been created to the tree by this point. All right, it has been created as soon as we add it. This thing adds it. That is annoying. So we can't easily remove a node from the tree once we already added it. Okay, we need some sort of different logic here. So that approach doesn't work. That approach doesn't work. So when we pass a declaration, let's try that again. So what we essentially need to do, we need to query whether we already have a declaration with that name in the tree. You know what? Let's just add the logic. So let's just actually keep a definition. So const non-const of decl. So let's give it a definition. So initially we don't have a definition. Null pointer. Bool has definition. If the definition is not null pointer, we make it a definition by setting the definition to ourselves. And then we set definition by giving it a definition. Okay. Right. And then we also don't need that weird logic. Okay. Check for duplicate definition. Check that we are allowed to add a declaration here. Okay. So back to here. So here we've got this one, and it doesn't have a definition. This is because when we make something a definition, we need to then resolve it. So how do we resolve that? So if decl has definition and shadow doesn't have a definition, then we want shadow set definition to decl. Else if the other way, so we don't have a definition but shadow has a definition, then we want to set our definition to shadow. Something like that. Right. Let's update the AST. Oh, actually, that's fine. So now we've got two globals with a definition, but the thing is, this will break as soon as we do something like that. Right? Because when we create this one, we shadow this declaration, so we set its definition to that one, but we don't set, but by this point, this one's already gone. So we need to do like one pass at the very end, I think, yeah. So instead of doing it right here, we do this at the very end. So we compile void resolve forward declarations. We can't do it at the very... Can we do it at the very end? I don't. We can't do it at the very end because then by that point we've lost the scoping information. We need to do that at the end of every scope, which is annoying. So what do we do here? Like if we do it here, we can't because the issue would be something like this. I have a right, we need to, at the very end, we need to figure out that this global refers to that one. But actually that is possible. Because we don't need scoping information. So my issue was, at the end, when we iterate over it, we don't have the symbol tables for the function anymore. And then we can't do proper scope name lookup. But we don't need to do proper scope name lookup because external identifiers are global, uniquely, global throughout the entire program. So we don't need to worry about scopes. So what we can do to resolve that is we just need to add every symbol to a symbol table, like every declaration, regardless of scope, that is external or static and doesn't have a definition yet, and then do a single pass over there, right? So we can do it at the end. So resolve forward declarations. So what we need to do is collect all definitions of external declarations in a map. So dryad symbol table. Lauf symbol, is that this thing? That one, maybe. As symbol ID, and then we want lauf deckel. External definitions. That's the type I want. That's the type. So external definitions. Okay, so for that, now I need to do a dryad visit node all. State dot actually visit tree. State dot not the deckel tree. State dot ast tree. That's the one. So I want to visit that, and I want to do something for declaration. Deckel. So if deckel has definition and not deckel, and it is external, so deckel linkage lauf linkage external, right? Then I want to add that to the map. Insert or shadow, deckel name, deckel. Okay. This shouldn't shadow in a well-formed program. Note, this can't shadow in a well-formed program, as we checked for duplicate definition. Yes. Let's just say that is. I'm thinking about whether we only check for duplicate definitions within the same scope, but you can't define an external symbol, you can't define it here. This would be a global. So we check for that. Okay, so now we've got all the external definition, and now we want to resolve all declarations of external symbols. So for that, we will up the entire tree again. If we don't have a definition and the linkage is external, then we want to look at the definition, look up the name, and if we have one, then decal set definition, that one. Okay. And then at the end, resolve forward declaration state. Let's see what that does. So we've got a global static with no definition, which isn't true. We've defined it. Wait, why is that marked as static? It shouldn't be static. It should be... Oh, the static here is not the linkage. The static here is the storage duration. So that is sense. So we've got an external global without a definition, which isn't true. Like we defined that right here. So this should be caught. So let's see what's going on here. This is apparently never called. Oh, this is never called because we don't actually have the tree at this point. The tree is only set here. So the tree was empty when we called that function, which is why it never ran. Okay, so that explains that. Now we should resolve that definition. Excellent, right? We don't have the marker for no definition anymore because we resolved it. Good. And we even got like the external declaration here that was also resolved. Okay. Before we tackle codegen changes, there's one thing that's probably not going to work, and that is if we have a local. So, right. Oh, it works. This gets its own definition, obviously. Right. Okay. I was thinking that because this is never resolved, but because it doesn't have a linkage, it gets its own definition. Okay. Then we need to handle functions. So the function is marked as no definition. Right. So we've got both function. We are doing a fancy logic for functions that we should get rid of for consistency with the way we're treating the variables. So this is because here the definition for global declaration. So this one, right, tries to look for an existing declaration here. Let's not do that. Let's always create an existing, a new one, so a new node in the AST. That we then insert unconditionally. And since if we have a body, we also mark it as a definition. Mark definition. Why does function declare? Not what's it called? Is it set definition? There was something. Is definition make. Okay. Not mark, make. I believe my language server died as well, so don't get any auto-completion at the moment. So we make it a definition if we have a body, and we get a segmentation fault. Probably, right. We're getting a segmentation fault because we're not handling it correctly in codegen. So, let's tackle that. So, we've got those. We've got the definition between has definition and is definition. So we have a definition if we can refer to some other definition that is our definition, but we are a definition if we are our own definition. And then we also want to get the definition. Right. So, because now during coaching, boy, today is really not playing performance day. This is not what I wanted. Okay. So we go over all declarations in the root, but if there are not definitions, we don't do anything. Because we now don't need to generate code for things that aren't definitions. Right. So now let me add. So now we only got one main function here, even though we're having two decl nodes in the AST, but only this one is a definition. Let me actually print that. So if we don't have a definition, if we are a definition, then we print definition. And if we print nothing, that means that something else defines it. Right. So now we've got marked when something is a definition. So that's the definition, and that's the definition, and only those generate code. So now the only remaining issue is we are printing 0 instead of 42. So two issues, like so. So now this will crash, yes. This will crash because this identifier expression right here, this one in the ST, this refers to this declaration. And then when we codegen, we attempt to look up a global variable for that declaration node. But no such global variable exists, only one for this definition node. So we need to teach codegen that we don't, so somewhere, here we've got a map of, for example, of globals. And here when we insert it, right. So that here we insert it when we like create a global for a declaration, we instead need to insert the global for the thing, global for the actual definition, but we don't know about that one yet. Because by this point we haven't actually created a global. So what we need to do, we actually need to do two paths here. First, we need to define all global variables. So we actually need to do like, because we need to add the global, then we can initialize it. So let's do the following. Let's populate this map. We need to populate that at the very beginning once with all the appropriate globals. So I can actually do the following. So first we create all global variables. This can be done in source order, since global variables themselves cannot depend on other globals. So if it's a global derived node trycast variable decl. If it's a global and it has a definition, then we do codegen global context global. Next, populate the globals map with all references to globals. So what I mean by that is same logic, but if we are not a definition, but we have one, then codegen global, not codegen global, context globals dot insert. We want to our declaration look up our definition. So we want to map ourselves to our actual definition. And that needs to be a variable declaration. Okay. So this handles globals. So let's handle that. So this would handle that particular case as soon as we've got so auto Adam global yeah, this creates like a pointer to the value assert we have added the definition above. Okay. So now this prints 42. And this prints 42 because we first create the definition for the global, and then we resolve all other declarations, add those to the map. Yes. What we are not handling correctly is we need to do a similar thing for functions. Because we can have something like A and B, and we want the definition of A equals B, and the definition of B equals A. Right? We get this error, forget to populate tables, because while we code gen for A, we don't have a definition for B. So we need to code gen B first, but when we code gen B, we don't have a definition for A, so we need to code gen A first, which obviously can't work. So we first need to declare all functions, then populate them. So next, declare all functions. So and actually, we can't iterate over the global one because that one is valid. Or maybe you need to use extern. Clang, does Clang require extern here? Let me actually see. Clang tested C. No, apparently not. So that one should also be valid. So we can't iterate over the top level declarations to find those. We need to find all of them. And the same is true for globals. So what we need to do, we need to visit the entire tree. And in our search for global for variables, decl, yeah, let's call it decl, yes. Then if decl storage dual, so if it's a global, an extern global. So this actually extern implies the storage duration. So if it's not, where did I go here? So if the linkage is not linkage, I'm in the correct namespace here, linkage external, then we return. Otherwise, if we're having a definition, we codegen the decl. Okay, and then we want to populate you, which means that if we don't have a definition, if we aren't a definition but we have one, then we do that logic. decal. Okay. That works. And then we need to do a similar thing for functions. Next, create a declaration for all functions. Can you have... you can. I'm just think. Let's go back on functions and consider globals again, because I believe the logic. So this one should still work. After I fix the compiler error. What are you complaining about? No, for mention function called for object of type lambda. Const qualifier. I don't have the precursor. But I do have C comments. Right, so that one still works. What happens if I... you can't forward declare static variable, right? You cannot do, you can't forward declare it. But that's actually not an issue. What would be so that actually works fine. Okay, so that actually works fine. Let's do a similar thing for function, but the thing is, how do I know? Right. Right. So similar thing. So let's actually unify. Let's do it in order and clean up later. So okay, create a forward declaration for all functions. So we need to do similar thing. We want to visit the tree. But this time we want the function that's only. And then in this case, regardless of linkage, but if we have a definition, we want to codegen. So we want to split codegen function into two things. Codegen function header and codegen function body. And this one uses something like that. And then returns the function. Whereas this one, context functions lookup decal. Let's unconditionally dereference here at this part. Okay, so something like that. And here we want to, if we have a definition, codegen function header, context decal, and then populate function map with all references to functions, right? That one actually works. So if we are having aren't a definition, but we have one, as definition, context functions insert decal the functions function decal. Okay, and then finally at the very end we codegen the function body. Right. We don't actually need the parameters here. we just need the size. Distant decal parameters. Decal parameters and how do I get that? Return count. Let's just duplicate this one. Actually, like I can query like the signature, can I not? Then function signature, right? I can. So if the output count. Okay. Now I still got to forget the populate table. Why is that? Right, this one is marked as no definition, which is the bug in the compiler, where we resolve definition. Why shouldn't you? But we've got the definition for those, so why isn't that one found? Why aren't you found? This controller mobile phone program. Like I insert every like I visit the entire tree and visit every declaration and insert it into the thing. Then I need to like, oh, this doesn't have external linkage. Right. What is the linkage? A block scope. Right, so it definitely has linkage. Right. Function has no storage class specified in our case. Then it has implicitly extern. Right. And in this case, oh, you can actually, wow. Okay. Let's implement that first, and then I worry about that annoying edge case that I just found. Man, maybe we're not getting to Aries today because the linkage stuff is way too annoying. So what I want to, right. So when I pass a function declaration in the compiler, declaration. No, the decal speci, right, for a function. So if it's in the global scope or if it is a function. Function implicitly has kind zero function declarator. Function implicitly have global external linkage. Right, so now this has external linkage, which means we find the definition, which means we resolve it, which means we're able to generate this code. So that's good. What I just realized now is in that clause right here, if we have a prior declaration, then we with extern, then we copy the linkage from there. Wow. So this means just because we're extern doesn't mean we have external linkage. So what this means is if we have something like this, static int I equals 42, extern int I. So in this case, this variable declaration marked with extern actually doesn't have external linkage, it has internal linkage because it's resolved as the declaration corresponding to that static one. Why? Like, man, this language. Storage class, right? Why? Like, what's the use case? Like, I don't get it. Okay. Let's just pretend I never read that and we'll continue on. So I believe we are now handling that one correctly. So we can now correctly handle those things except for things like so. So global cloc and global, which was our initial use case. Do we handle U? I think we should. No, because we are still treating it as a local variable. So what happens if I just go ahead and say codegen variable declare? Not here, not here, not here, right here. Storage duration static. Then we codegen. We don't actually want this code. So, right. What happens if I do that? Still treating it as a stair. The issue is actually not in codegen. Codegen does everything correctly. The issue is that this doesn't get static storage duration, even though it should. So let's do that and say that default storage if the scope is global, or we have external. Like as soon as we have external, we also have static storage duration. Yeah, let's just pretend the way it works like that, because I prefer to live in a world where it works like that. So if the linkage is external, then we are have a static storage duration. Right. So now you have static storage duration, and now we actually print 42. Great. So let's clean up the code a bit. In codegen here. So we now got, let's merge the populate one. So we visit so we can do 2 visits. So right. Add lauf forward declarations for all definitions. So function declare. Okay. Resolve is the next step. Resolve declaration to the lauf forward declaration, which is this step. So that step. And then finally we can generate code for all functions. Declare gen function body declare context declare, but only if we have a definition. Okay, so we create forward declarations, we resolve the other forward declarations so we can correctly refer to them, and then we generate code for all functions. Good. I just realized that I've broken something. Namely, I've broken something like oh, actually, I haven't broken it. So I was word, I think. So let's try. Do you still work? Wait, why are we not generating code for the const export ones? Okay. We are apparently... What? Why are we not generating any code for them at all? Okay, so I definitely broke something. Yep. So they are definitions, and as such, we should codegen them at some point. Right? Because... Oh, right. We only doing codegen globals if they have external linkage. Apparently, const export doesn't have external linkage by default. So we need to... so if the linkage is not external, if we are definition, or we don't have external linkage, codegen us. In the case of internal linkage, actually that is confusing. Okay, so I need to check, only worry about globals. Storage duration, so storage duration static. Okay, in the case of internal linkage globals, they cannot be forward declared. So we can also codegen them immediately. Cannot be forward declared and don't refer. Actually, they can refer and we can't codegen them. So this breaks, and man, this is confusing. Yeah, this breaks. Okay, so we also need to do like this two-step dance. So instead of codegen and global, we also need codegen global header. We can't add them a header because we need the data. What to do. So I believe the issue is that... Actually, I don't know what the issue is. Why are you crashing? We added the definition above. Oh. This is an or. Okay. Okay. So, but like this breaks in the following case, I'm assuming. No, actually, that's fine. Okay, I need to rephrase the code. Okay, so if we are at globals, don't need to participate in the two-step forward declaration. Actually, they do. So many edge cases, because I can have the following. That one. And that one will break. Yes, it breaks. So that one breaks because when we try to add the definition for that global, we want to take its address, but by this point we don't know about it yet. But that's actually fine. That's actually fine. Because we can immediately go to the definition. So what we need to do is, like the first step, we need to generate a definition for all globals. Right. So for all globals, we need a definition. Which means that we need to do something like, if we already have the global. Okay. not, so if we don't have the global context, globals contains the definition. So if it's not static or if it doesn't have a definition, then we don't care. So if we don't have the global, then we add the global. Right. Something like that. Now cast variable declare. So yeah. This should work. No, it doesn't work. Okay. Why don't you work? My idea was as follows. If we, like, as soon as we reach the first name of a global, we generate the definition. So at this point, we generate the definition for the global called global and set it to 42. Then the next one is this pointer definition, and we can have a global that we can refer to. Except I know what the issue is. So if it's so we already have the global, but the map from global to other global contains that entry and not that entry. So when we resolve that identifier expression, which refers to that entry, we don't know which is the address of that because we only have an address for that one and not for that one. Okay. I don't exactly know what's going on either, but it's, I think that solves it. So we need to, if we aren't a definition, I will add comments later on. But let's, so if we aren't a definition, then we also do that logic. Like so. And now I believe we don't need you for functions. Okay. Nope. That didn't work either. Why? So now my thing is that if Deckel itself is not a definition, then we need to add ourselves to the map and not just the definition. Man, this is confusing. Oh, I just realized there's a way simpler solution. Okay, I vastly overcomplicated it. Instead of attempting to insert all the duplicate ones, let's just when we update it, man, this is, so instead of looking up the variable Deckel, let's just look for the definition. Right. That just solves everything. Okay. Okay. Because as soon as we have, like, we always codegen it. Actually it doesn't, it only solves half of that. Okay, but the first thing that I'm going to do, is because I'm getting annoyed by all the casts I need to do, is I'm shadowing a couple of functions here. So I get like the proper types. So this one returns a variable Deckel, nodecast variable Deckel, Deckel definition. So then I don't need to do all the casts. And then similar for function. Okay. Because I've been getting annoyed having to do that. Function Deckel. Okay. So now I can just look up the global variable, the definition of that. And similar for functions. Instead of looking up the decal, we are looking for its definition. Okay, and then I don't need you, and I also don't need you. So what happens now? Okay, still not supported. Okay, let's work this logically. So we reach this line, at which point we generate an asm global for you and insert it into the map. And then when we do that, it should be resolved. So why aren't you... So why aren't you being resolved accordingly? Let me actually see what's going on here. So we expected we are here. What's the thing called? Oh, and we not storing the name. Declaration, but you have a name, right? Right. C string context AST symbols. Yes, I meant to use that. No, never named string. What's it called? Wait, there is a never named C string. Okay, debugger doesn't like me. And now I broke my setup. Okay. Let's try that again. Backtrace, what's it called? Okay. I want to figure out codegen expression. Oh, for the... Oh! We're not actually in the constant evaluation code. We are here. Right. So the constant evaluation code works, except that we're not actually generating a global for you. Man. So. We're generating global for everything with static storage duration. That one has static storage duration. It has a definition, so we should generate a global for you. Because this one doesn't. This one, I was missing a knot here. Okay, and now I'm getting that error again. Okay, let's backtrack a bit. Does this one work? That one does work. Okay. Does that one work? That one creates two globals. Why are we creating two globals? So we are only creating a global if we already like. Okay, let's work it. So We are in the first global, so we code gen it, right? This is the global. Right, this is global. All right, we don't actually know. Okay, next up. Okay. Helps if we actually get the definition and not just cast it to ourselves. So now we create global and pointer, and that one still works. Okay, and we're only creating one. So that caused that error, right? Because now this one should work. Right, that one works. And similarly, that one also works. Okay. And we can even do things like that, I'm assuming. At print42, it still creates a local variable for some reason. Probably for pointer or something. Okay, let's worry about that one later. Oh, actually, let's do it right now. So why are we creating a local variable? Let's figure that one out. Local variable. Right here, we're only creating it if the static storage duration is not static. This one is static. This one's actually, this one we're creating a global variable, which is correct because that is a local variable. Okay, because it's not static. Need to make it static. And now we got a global pointer. Okay. Okay, so what's the current logic that we're doing here? We're creating forward declarations. And then we generate code for all functions. Right. So, and here the trick is that we generate the definition for global as soon as we have the first declaration. Okay. For global, we generate the definition as soon as we have the first declaration. This is because the initializer this what happens if we don't. So the idea was the following issue, that we needed to get the address of a global, we need to know about the global. So we need to create the definition for the global here already, so we can get the address here. But this would then obviously break if the initializer for global refers back to, right? Refers back to that code. But that one's actually not allowed. And I believe we catch that. Apparently we don't catch that. Because it... Wait, that is allowed? Clang doesn't C23, is that a thing? C2x. Okay, it doesn't support const expr yet. But, like, is that allowed? Can we, like, get the own address, like, initialize a global with its own address? Or rather, its own value in this case, right? Can we, like, we are allowing it, but does the standard allow it? So it needs to be like a constant expression. Named constant. What's a named constant? This applies the no. Can we dereference? Can we dereference in a constant expression? Yeah, we cannot. So we need to, that one's actually not allowed, so we don't need to worry about that. What? But like in principle, yeah, I think we're actually good. So let me try to phrase that in a comment. As soon as we have the first declaration. This is because later const. This is because later global may be initialized to its address, so we need the value. So we need Adam global to exist, right? So we need generate the definition because later global may be initialized it, so we need it. We can already initialize it. Right. Something like that. So extend void A, extend void B equal B, B and A. That's an issue. So we do have cyclic dependencies. So we need to forward declare them. So we need to forward declare the global, then generate the body, like similar. Then so we need that. The issue is we can't forward declare globals in lauf. We can need to like specify the initializer as soon as we create the global. But since I'm not going to get to arrays anyway, let's just switch project and add that to lauf, then add support, and then just so we're done with it. And then I never want to think about linkage ever again. Okay, so lauf. We want the ability to, when we create a module, we want to declare a global, adds a global that hasn't, without specifying an initializer yet. Yes. Lauf Adam add global declaration. And the layout. And then we want a later function to specify the initializer. Right, which means so we need to then add the initializer later on, which means we need to add like duplicate all of those functions. Okay, so marks the global as 0 initialized. Set 0 init. Max global, let's call it 0 initializes the global. And then we call it the global 0 data. Okay, like so. Initializes the global to the specified mutable memory. New data. Actually, at this point, it's probably like mutability is something that we can specify here. It's mutable to the specified data. Load Adam global data, like so, and then max the global marks the global as being initialized by native code. It is a view into native memory. Native data. And then we need the global. Okay. So that's the sort of API we're working with here. So we've got, no, I wanted to put you first. So we can create a global, optional mutable, and then give it initial data, give it 0 data, or mark it as native data. And since I'm allowed to do breaking changes in lauf, let me delete those functions and make everything in terms of those. So we create a global, and then separately we can specify the initializer. And we need that for lauf because we can call this function without evaluating the initializer yet, and then we can later initialize it properly. So that's good. Right. So let's implement those functions. So when we want to add a global, we want to construct a global with layout, alignment, and is mutable. So the only constructor that we want is layout, alignment, and actually layout, size, alignment, and then let's use the permissions. That's all. Actually, just thinking about it, the API, but we need the previous API. When we create a native global, we don't specify a layout. So, right. So actually the API needs to do something similar. So add global memory with the specified layout. It is 0 initialized by default. Like so. And then we can initialize it and we don't need that function. And then we want to have add global memory that is a view into native data. Like so. And then like those are the two APIs, and this one cannot have an initializer because it's native memory. So that's the actual API that I want. So this means that we need two constructors, one for the native global and one for the other one. And I need to actually figure out whether or not we are having a native global. So native global, what I'm currently doing to keep it now whether or not this is like an actual global or a native one is if the size is 0. So is native global. So if we don't have memory and the size is 0, then it's a native global. Okay. Yes. So then in the creation function, so create a global like so. Adds global data, right? So let's rename it a bit. So add native global. Native global and totally call the other one that's not native. Add global. Yeah, let's call this one add global and add native global. Initialize the non-native global to the specified data. Okay. So that is the function. Okay. Then the native global. And instead of it's mutable, I need to translate here to the permissions. Read write, otherwise read only. Okay. And then right here, I don't specify a layout and an alignment, but just use the permissions. So that's the other constructor. And then here I need to do an assert layout that size greater than 0. Okay. Then we want to set the initializer. By going so if we have memory, we just specify that accordingly. Mod what's it called? I'm using it somewhere here. And used it memdup the data layout size. Okay. Has the size member. Okay. So now that's the new API. And I believe everything should, as soon as we update it, the code that uses it, this should actually just work fine directly. So here, for example, build string literal, lauf, Adam, we add a global, size 1, that is not mutable, and then we initialize it. What's the function? What did I call the function to initialize it? Set global initializer. Let's call it like that. Lauf Adam set global initializer. Mod global the string. And then I can return the global. We don't have a constructor that takes permissions. Permission. Parents. Okay. Right. If it's a native global, just update the API accordingly. Add native global mutable. What are we doing here? Right. We don't want native globals. Don't want native globals. And then here add lauf Adam add global. So we add a global that is mutable. Then we set its initializer to ABC. And then here we're creating a global called no null ABC. Its layout is 3. It is const, and its initializer is the first 3 bytes of no null ABC. Add global mutable, add global mutable, mutable, mutable. Add global not mutable, what was it, name.cstring, data.cstring. So here we've got data size, align void star, they're not mutable, and we set the global initializer to data.cstring. Let's format it like that. Add native global. And here we want mutable global. Mutable. State G. Data C-string. Your mutable. And here the layout is data size align of void star. Okay, builder.cpp 82. I know what the issue is. I think. That's builder.cpp. So we've got this API build string literal, which creates like global only once. Or maybe I just messed something up. So mod string since size 1, it is not mutable, and then we set the initializer to that string. So that part of the API appears to be correct. Maybe I messed something up in the test. Test builder 82. We build a string literal ABC, and this is the same as mutable ABC. Right, this one is mutable. I swapped those two. Right. Okay. So now that one is the API that we want. We can now declare global and initialize it separately. Split global declaration and initialization. Which means we can now finally finish that code. Update you to the latest dependency. Get a compiler error because we changed the API. now we're getting a compiler error. Right. So U is native global. This is mutable. And here we can now split U finally. Codegen global header. Where we can just do qualifiers if is const auto global lauf adam add global context mod layout. It's mutable if it's not const. Like so. And then here in the actual body, we're getting the global from the context. Look up decal. And then if decal, if we have an initializer, then we do constant eval and say hello adam set global initializer context mod global init.data. And I'm not getting nothing. And now we can vastly simplify this code by just saying that if we are having a static global, that is a definition. So if we have an global, that definition codegen global header context decal add lauf forward declarations generate body for all forwarded lauf declarations. So same logic. Codegen global body. Let's just call it body. Let's call it init. And now it does work. Yes, it does. Well, not quite. We want not has definition, is definition. Not has definition, is definition. And now it just works. Right, we've got two globals that contain the address of each other. And yeah, so that took a while. And the same is true, we can also do like have the mutual recursive functions. Right, that one also works. Okay, let me just take those directly and make them a test. Mutual recursion. Okay, good job. So now we, this was the because we just needed to separate, like the first need to generate a declaration and then we can generate a definition. And I just was vastly complicating the logic because yeah, just that could have gone a lot quicker. What happens if we like the other things should still work if you do like extern int global 0 print global, that should print 42 and it prints 42. Okay. Forward decal.c. Write a test for that. man, that took way too long. And now there's one thing that we should handle. That is an error. Because external variables cannot have an initializer, as the IDE says. So when we pass something like when we pass a declaration somewhere in here, like if we create, there's something here in a declarator. If var declare. So if it's not a definition, but you have an initializer, variable forward declaration cannot have an initializer, which is the error. Right, variable forward declaration cannot have an initializer. Okay. Unfortunately, because that took almost 2 hours, I'm not starting on arrays. I might stream again later this week, but for now, that's all I have time for. So support variable forward declarations. Thanks for everybody who stopped by, and until next time.